get started. Alright, so today we are working on polynomial expressions. These are things, and let me see if I can, I was going to try to increase it, but I think it's going to like it. Alright, so when we're adding, subtracting, multiplying, I'm sorry, what? This bill's come down if they need them. Anyway, polynomial expressions. When you are adding like expressions, or adding polynomials, or adding monomials, binomials, trinomials, those kinds of things. Remember, and this again is just a review, we're adding things that doesn't matter necessarily about the coefficient or the number in front. What does matter are the exponents and the variables. So in this expression, and some of y'all did not do a very good job, and I put this on several tests to try to jog your memory several times, but it never, I'm not quite sure why it never stuck, I guess. But when you're adding variables like x plus x, you don't add the exponents. When you multiply, then you add them, or when you divide, you subtract. But this is just a simple example of adding polynomials. So you have to combine the like terms. So the like terms are those things that have the same variables, same exponents. So in this, we've got a trinomial added to a trinomial. So 3x squared plus 4x minus 7, and all of that is added to 5x squared minus 2x plus 4. So you're just adding, and they go through this big, long example where the first line, they took out the parentheses. Second line, I guess somebody can't make up their mind what they want to call or not. So they took out the parentheses in that first line. The second line, they started grouping things together, which really I don't require. I mean, all of this, I don't feel like you need to do. You can do it if you want, but I don't feel like you need to do this. As long as, remember what I did, when I would draw an arrow, like I would say 3x squared or 5x squared, which is how we did it. So 3 plus 5 is 8x squared. We don't add the variables. 4x plus negative 2x, or 4x minus 2x is 2x. And negative 7 plus 4 is negative 3. So the adding, most of you got. That was not too bad. Then we got down here to the subtracting one, and what happens to that subtraction? It gets what? Somebody said it. Distributed. It gets distributed to everything in here. So this is 6x squared minus 2x squared, which is where the 4x squared comes in. This is 4x minus negative 2x. So minus, the minus is a plus, so 4x plus 2x, there's a 6x, and negative 7 minus 4, which is negative 11. So you got to remember, this negative, this subtract symbol, gets distributed to everything in parentheses. A lot of you will do this first one, the first term, but then you'll forget that minus goes there and that minus goes there. So those are just real simple examples about adding and subtracting. Then we get into the, what do we call this? FOIL. First, I mean, they do all that. First, outer, inner, last, where you're multiplying two binomials. So you multiply the first two terms, and this is where you add the exponents. So 4 times 2 is 8. You multiply like normal, but then you've got two x's, x1 and x1. So 8x squared. And the outside term, 4x times 5. That's where the 20x comes from. Inside term, 7 times 2x. There's the 14x. And last term, 7 times 5 is the 35. So then when we multiply two binomials, 2 times 2 is 4, correct? So there should be 4 things right here, and there are. 1, 2, 3, 4. Normally those two middle terms would combine. Most of the time they will, and that's where the 20 plus 14x gives you the 34x. So they give you the same kind of example, except this time they just made it a little bit harder. They put some minuses in there. So that's about the only difference in there. Hey! That's why we've been hearing the phone, they don't ring once and then it won't do anything. Okay, thank you. Hey. Okay, all right, sounds good. Bye-bye. Hello? Hey. Okay, I'll send him right up. Bye-bye. So you want to go to, Mr. Forrester? Alright, let's see if anybody else calls now. Okay, anyway, so back to this, just leave the door cracked and get back in. The binomials multiplying the first power and the last, so 8x times 7, there's your 56x, 8x times negative 3x, so minus 24x squared, negative 1 times 7, minus 7, and negative 1 times negative 3x, or 3x. So the same thing, it doesn't matter where the variables are, you're still doing the FOIL. It just so happened that this time, they kind of switched these two, so they're in different positions. So it's not necessarily the two middle terms that combine in there. Alright, let's see, we're not going to use this time to do these videos, but what we are going to do right now is you are going to be given a floor plan. Do you know what a floor plan is? A floor plan? Okay, so if I did like a floor plan of the main hall, and I divided it up, here's the that's not what I want. Here's the hallway, and then I divided up, let's see, my room, alright, so then we have the bathroom, we have the hallway, Alright, so this would be like a very crude floor plan of the main hall in the hospital. Now on there, they would have dimensions. Maybe these rooms are, let's make it simple, 30 by 30. So that's 30, that's 30, so on and so forth. So you have dimensions on there. Alright, so this time, you're going to have a floor plan. It's going to be a house floor plan. Except for, instead of giving you numbers, it's going to say like, alright, the length is x plus 2 and the width is 2x minus 4. So say something like that. And you're going to have cards or questions that are going to ask you, alright, what's the perimeter of Mr. Watson's classroom? Alright, well, how do we find perimeter? How do we find perimeter of anything? The length of all the sides added up, right? So the perimeter is all the way around. If I asked you what was the area of Mr. Watson's classroom, what would you do? You would have to multiply, because area is length times width, or whatever. If it were a circle, or use whatever area formula. Alright, so you're going to be in groups. You're going to have a floor plan. And then you're going to have task cards. So like this one says, find the length of the dining room south wall. You know, find the length of the dining room south wall. But what you're going to turn in to me is going to be, your answer. So you've got 16 cards between you and your group members. You know, put your answers on